Okay, so in this lesson, we're going to be talking about solving radical equations that only have one radical in them. Now, a radical is just a square root. So as you can see in this equation here, we have the square root of 2x plus 1 equals 3. So this square root right here is what makes this a radical equation. And it's an equation because it has an equal sign. So the first step into solving these is to make sure that the square root is completely isolated on one side of the equation. And in this case it is already. So what we're going to do is we're going to do something to both sides in order to unlock what we have under this square root, which is this 2x plus 1. So the opposite of a square root would be to square both sides. So we put parentheses around the entire left side and the entire right side, and we put a little 2 up here. That little 2 is indicating that we are squaring both sides. So when you square something that is a square root, that in a sense cancels with the square root since they are inverses of each other. So what we're left with on our left side is 2x plus 1 is equal to, now on the right side, 3 squared. Well, 3 squared is equal to 3 times 3, which we know 3 times 3 is equal to 9. So our right side is 9. So now we're left with just a normal algebraic equation. So remember, what you do to one side, you have to do to the other. So we're looking for x. So we want to get this x. We want to get this x all by itself. So right now we have this 1 in the way. So we subtract a 1 to both sides because we do the exact opposite of what we have here. So we have 2x left on the right side because 1 minus 1 is 0. And that equals, well, 9 minus 1 is equal to 8. So now our x, it's still not by itself yet. We still have this 2 in the way. So this is 2 times x. So the opposite of multiplication is division. So we're going to divide both sides by 2. And 2 divided by 2, well, anything divided by the same exact thing is equal to just 1. So on our left side, we're left with just x. And now we have to figure out what 8 divided by 2 is. Well, the way you reduce fractions is you ask yourself, what number goes into 2 and 8 equally? Well, we know a 2 goes into 2, and we know a 2 goes into 8 because both of these numbers are even. So you divide the top and the bottom by 2, and we get, what's 2 divided by 2? It's 1. 8 divided by 2 is 4. And anything over 1 is just that number. So 4 is one of our potential answers. The reason I say potential is because if we're solving an equation with the square root, we always have to check the answers that we get. So I usually go off to the side and just write check, and I'll put a little note, we're checking x equals 4. So then underneath that, we're going to stick the 4, which is our answer we got, into the square root. Or I'm sorry, not into the square root, into our original equation, which is this equation here in black. So now we have the square root, and I'll separate the check from the actual problem. 2, now since we're plugging in the 4 into this x, you always want to put parentheses. So we have 2 times 4 plus our 1 is equal to 3. So we have the square root of What's 2 times 4? That's 8 plus 1 is equal to 3. So what's 8 plus 1? That's 9. So the square root of 9 is equal to 3. And the square root of 9 is 3. So 3 equals 3. So we're happy. This makes sense because 3 does in fact equal 3. So it works. So our ultimate answer is x equals 4. If we were to get something here like 2 is equal to 3, well, there's no way that 2 can ever equal 3, so it doesn't make any sense. So this answer that we were checking would not have worked. But in this case, our answer did work. So I want to do a little bit of a more challenging problem than that. And that problem is the square root of x, sorry, that's a sloppy x, of x plus 15 x plus 15 minus x is equal to 3. Well, remember on our first problem I said the first step to solving these problems is you want to isolate the thing with the square root onto one side. Well, we have this negative x here, so this problem isn't how we want it to look yet. So the first step is to do the opposite of what to the x. So this is a negative x, so we're going to add x to both sides. So those cancel because negative x plus x is 0. And you're left with on the left side the square root of x plus 15 is equal to 3 plus x. Now the square root is isolated on the one side all completely by itself. So here we have to get rid of the square root. So how did we do that last time? You just square it. But you have to do that to the same thing to the other side as well. And in this case, we have to put parentheses around it because we're squaring the entire side. You can't just square the 3 and then square the x. You have to put parentheses and square the entire side. So that and that cancel. So we have x plus 15 is equal to, now when something is squared, it just means, for instance, in our last example, we had 3 squared, which means 3 times 3. In this case, we have 3 plus x squared, so it's going to be 3 plus x times 3 plus x. So the first thing we got to do is distribute this out. So I always like to draw arrows. It's always the first thing times the first, and then the first times the second, then the second times the first, and the second times the second. So on the left side we have the same thing still. We have x plus 15 is equal to 3 times 3 is 9. 3 times x is positive 3x. X times 3 is the same exact thing that we just had, 3x. And then an x times an x is a x squared. So now we have to simplify. We see that this 3x and this 3x aren't common. It's kind of like you're saying you have 3 oranges and you went and picked 3 more oranges. So how many oranges are you going to have? So you have x plus 15 equals 9 plus 3x plus 3x, or 3 oranges plus 3 oranges, is going to be 6 oranges. So 6x plus x squared. Now whenever you have an equation that has an x squared, which we call a quadratic equation, you want to get this whole equation equal to 0. So in this case, it's going to be much easier to move the stuff on our left side onto our right. So we're going to subtract. Here, let me do that in red. We have to subtract 15 because that's the opposite of 15. And I like to line it up with what we're going to combine it with. Since the negative 15 is it's a constant, it's a number, we're going to line it up with the other number on the other side, and we're going to do the opposite of x, because to make those cancel, and we're going to line that up with the thing on the right with the x. So we have now 0, because everything here canceled, is equal to, well, what's 9 minus 15? That's going to be negative 6. 6x minus x, or 6 oranges, and then you went an 8 in orange, you're only going to have 5 oranges, plus x squared. Now, I like to put this in order from highest power to least. So, just because we have lack of space, I'm going to erase that and put it back in order. So here, x squared is with the highest power, plus 5x minus 6. So when we look at this, we're not done solving it. We still got to solve it. So what we're going to do is we're going to factor this. So we have 0 is equal to, and then we have to factor this. Well, the first two things are going to multiply to this. So we have an x squared here. So an x times an x gives you an x squared. Now the last two things have to multiply to give you negative 6, but when you add them together, has to give you a positive 5. So I see that a 6 and a 1 will give you 6 if you multiply them together. But is there a way that we can make 6 and 1 add up to 5? Yes. If you put a negative 1 and a positive 6. 6 times negative 1 is negative 6. A positive 6 minus 1 is a positive 5. It's still equal to 0. So now what you're going to do is you're going to set each of these things to 0. So you have x plus 6 is equal to 0. And we have x minus 1 is equal to 0. So I'm going to erase some of our previous work just to make room. I'll rewrite the original equation. So our original equation is the square root of x plus 15 minus x is equal to 3. So we have this here, so I'll rewrite it. So we have x plus 6 equals 0. We have x minus 1 is equal to 0. So now you want to do the opposite to solve for x. So the opposite of positive 6 is negative 6. And the opposite of negative 1 is positive 1. So those cancel and those cancel. So one of our answers is x equals negative 6. And our other answer is x equals positive 1. So these are our two answers. Are we done? No, we're not, because remember, this is a radical equation. So what do you have to do when you get your answers? You have to stick it back in to check it. So the first thing we're going to do is we're going to check negative 6. So we're going to stick it into the original equation. So we have negative 6 plus 15 minus a negative 6 is equal to 3. So negative 6 plus 15 is going to be negative 6 plus 15 is going to be 9. A negative times a negative is a positive, so we have a positive 6 is equal to 3. Well, we know the square root of 9 is 3 plus 6. Well, 3 plus 6 is not equal to 3. So it is not equal to 3. So what that means is this x equals negative 6 is not a solution to the original problem. So now we have to check if x equals 1 is a solution. So we have the square root of 1 plus 15 minus 1 equals 3. 1 plus 15 is 16. A negative times 1 is going to be negative 1 is equal to 3. Well, the square root of 16 is 4 minus 1 equals 3. 4 minus 1 is 3, and 3 equals 3. So we're happy. Woohoo, we're happy. And it works. So let's get a nice big green check mark. So x equals 1 is the solution to our original problem.